Welcome everyone, and thank you for joining me. My name is Idan Roth, and together with Boris Konstapolsky and Sophie Sherman, we are excited to present our research in progress titled Jumping into Deep Waters: The Impact of Industry Experience on Student Motivation. This study was conducted at the Academic College of Tel Aviv-Yafo in partnership with a global high-tech company, and we're delighted to share it here at the 15th International Conference on the Knowledge Management in Siena. Before we jump into deep waters, I want to express my sorrow for not being able to join you and meet you in person. I hope we can all meet next year. Our research was motivated by the well-known gap between academic preparation and industry expectation. While technical skills can be relatively easy taught in a classroom, soft skills like communication, teamwork, and self-efficacy are much harder to instill. We wanted to know, can embedding students in a realistic industrial environment foster stronger motivation and better preparation for the real-world careers? There is a growing recognition in the industry that soft skills are not just desirable but essential. However, traditional coursework often fails to replicate the dynamics of real-world settings. Motivation, which is a critical driver of engagement and learning, may be enhanced or hindered by how closely a course mirrors industry reality. We sought to investigate how this plays out in a practical, industry-integrated course. We asked three core research questions. First, how does student motivation evolve throughout a practical course? Second, how do the five key dimensions of science learning motivation, intrinsic motivation, career motivation, self-efficacy, grade motivation, and self-determination change over time? And third, what student characteristics influence these motivational changes? The course under study was an elective titled Introduction to Open Source, offered to third-year information systems students. It was developed in a close collaboration with a global high-tech firm. Students worked in teams, were mentored by industry engineers, and had to manage tasks, communicate effectively, and use tools typical of professional environments. The course was intentionally designed to be demanding, simulating industry conditions from the start, even through the screening process. Our study was conducted in two iterations. In 2020, we used qualitative interviews to explore students' motivational changes. In 2021, we applied a qualitative tool, the Science Motivation Questionnaire tool, administered at three stages: before, mid-course, and at the end. This allowed us to observe motivational trends and triangulate findings from both qualitative and quantitative methods. Interview data revealed a V-shaped pattern in motivation. Students began with enthusiasm, experienced a drop in motivation during the middle of the course, largely due to challenges and a perceived lack of support, but regained confidence by the end. Students described the experience as both enriching and overwhelming. The reflection gave us deep insight into how immersion in real-world environments affect their mindset. Our quantitative findings confirmed the qualitative trajectory. among the 14 students surveyed, we observed a statistically significant V-shaped trend in motivation over time. High motivation at the start, a dip in the middle, and partial recovery by the end. This pattern suggests that emotional journey students take during intensive industry-linked courses is dynamic and complex. Digging deeper, we looked at the 5 SMQ factors. Intrinsic motivation showed a statistically significant change. Self-efficacy did not, and the others were borderline. Interestingly, women's motivation dropped more than men's, particularly mid-course, and did not fully recover. These gender-based differences suggest that support structures need to be more personalized to meet diverse needs. Students emphasized that mentorship was crucial, but often insufficient. Many felt abandoned mid-course, which undermined their confidence and self-efficacy. While some students had enough prior experience to cope independently, others struggled. These findings highlight the need for structured, consistent feedback and emotional support, especially in high-pressure environments. Our interpretation is twofold. First, motivation is realistic. High-stakes learning environments fluctuates with challenge. Second, to maintain motivation, course designer must provide clear expectations and robust emotional and pedagogical support. Gender-sensitive strategies and personalized mentorship can help close the gap between enthusiasm and exhaustion. Our study contributes new empirical insights into how student motivation evolves during real-world, industry-aligned academic courses. It provides rare, first-hand evidence of the dynamic nature of motivation, capturing a V-shaped pattern of initial enthusiasm, mid-course decline, and partial recovery. This reinforces the importance of emotional and pedagogical support in industry-simulated environments. The study also validates the Sign Motivation Questionnaire, or SMQ, as a useful tool for evaluating motivational changes in technological education contexts. Importantly, we offer actionable guidance for designing courses that aim not only to teach hard skills, but to cultivate self-efficacy, resilience, and engagement, skills critical for the workplace. Like any study, ours has limitations. First, the sample size was relatively small, which may limit generalizability. Second, external factors, especially the COVID-19 pandemic, disrupted the first course iteration and affected student engagement. Third, mentor involvement varied widely and was not standardized, potentially impacting motivation in inconsistent ways. Finally, while the SMQ provided a structured lens on motivation, it may not capture all relevant aspects of students' experience, particularly in complex industrial settings. These constraints highlight the need for further investigation before drawing broad conclusions, but they also point to clear directions for improvement. Building on this research, future studies should involve larger and more diverse student populations to validate our findings. We also recommend exploring alternative tools for measuring motivation, perhaps combining SMQ with qualitative or behavioral data. Additionally, examining long-term effects such as how these experiences influence job readiness or early career success would be valuable. Lastly, we see a strong need to standardize mentorship approaches across industry-integrated courses. Doing so could help mitigate motivation dips and better support students from all backgrounds, especially underrepresented groups. These next steps will deepen our understanding and enhance the impact of practice-oriented education. Thank you for your attention. You're welcome to reach out with questions and feedback. We'd also like to acknowledge our students and industry partners whose cooperation made this study possible. Thank you and see you next year.